So we're going to review about 9 examples today that are all application questions for exponential growth or decay. And a few of them are going to start off like review. We've worked with these concepts already. And the other questions that follow will also seem like review, but we're going to, apply different methods here for efficient purposes. You still have the option to use whatever technique you'd like, but right, we want to work under accuracy and efficiency. So some of these examples, we're going to highlight those methods. So first question: your yearly expenses at a university have increased from 16,000 to 24,000 in the last 4 years. What's the annual growth rate in expenses, right? And then if this continues, what will be the expenses 5 years from now? So two parts to the question. When I'm looking at this scenario here, I can see that the initial value, the starting value was 16,000 and the final value was 24,000. And that took place over a 4-year period. So we can say A sub 0 is 16,000, A of t is 24,000, t is 4 years. And what we just don't know is we don't know the 1 plus r value, right? That growth rate. And then to convert it into its percentage growth. So here's what we would do, right? So we'd first set up 24,000 equals 16,000 times the quantity 1 plus r to the 4. First thing we want to do here is just like we've done in the past, isolate the variable term 1 plus r to the 4. So we're going to divide by 16,000. Now that simplifies to 3 halves, 1.5 will work. And then we need to isolate 1 plus r. So we want to undo this exponent of 4. Taking the fourth root of both sides is pretty natural. Technically, this is an even index, so you would be taking a positive and negative value into play. However, since this application is exponential growth and we're solving for an r value, all of our r values are going to be positive. So we would just use what we call the principal root here. So we take the fourth root or raise both sides to the 1/4 power, and we get about 1.1066 equals 1 plus r. Again, don't round this value too early. 4 decimal places is very safe. Solve for r by subtracting 1, and then we end up with r equals 0.1066. As a percentage, we multiply it by 100. It gives us about 10.68%. So the growth rate in this case is of 10.68%. Now, second part of the question says, if this continues, what will be the expenses 5 years from now, right? So what we want to do is calculate 5 years from this point forward, right? So now, if you read the question correctly, yearly expenses have increased from 16,000 to 24,000 in the last 4 years. Now, it's not clear when time 0 is. In this case here, time 0, t equals 0, is your initial value, 16,000, right? But someone could also interpret this as right now is 24,000 times 0. This would have been 4 years earlier, this 16,000. So you can work with 24,000 as your a sub 0 value as long as your t equals 0 value is it corresponds to 24,000 and not 16,000 as it did down here, right? So we can set it up 24,000 equals 1 plus, now this is our growth rate again. Now this should be the exact same 1 plus r value that we ended up with here. And then we raise it to the 5th power, and that'll take us 5 years from now, which would be approximately $39,840. Next example. Find an exponential function f such that f sub 0 equals 40 and f sub 2 equals 90. Now, the way this was presented in class was take this function notation and create a data point or a coordinate point, right? 0, 40, 2, 90. Alternatively, you could represent this notation in a table of values as well. Table of values are coordinate points, right? So I wouldn't recommend the table of values over 2 data points or vice versa, but just showing you a different way to represent it. So XY, 0, 40, 290. Some of you right now already understand that the A value in this case is going to be 40 from the exponential lesson we studied previously, right? So if you turn around and say A is 40, then you have another data point, an X and a Y, and we're going to substitute that right into the equation Y equals A, B to the X. A is 40. And then we take the second data point and substitute these values in. X equals 2, y equals 90, drop them into the equation right here, and then solve for b, right? So we're first going to divide by 40. You can reduce that to 9/4 or 2.25. It doesn't matter. If this is a decimal, do not round it, right? You don't want to round anything here until the end. Square root of both sides. Again, plus or minus should apply, but in this particular case, we're not going to work with negative bases. Therefore, b is 1.5 positive only. Once I have b equals 1.5, I have our equation. Y equals 40 times 1.5 to the x. Now, technically, this y right here should actually read f of x, since the original problem is in function notation here. So this y should actually read f of x, just like this. F of x equals 40 times 1.5, close my group, to the x power here. Next example. Actually, we're going to pause on this one for a second slide.